This is the syllabus what we are going to discuss in today's class and forthcoming classes. First unit, Linux environment and shell programming. It is like 6 hours lecture. Linux philosophy, distribution, kernel, user space, CLI power. Second topic, file system hierarchy, permissions and links, FSS, LS command, chmod, chown, umask, link, hard link and soft link. Third topic, bash scripting, variables, coding, test, exit status, control flow, case, command substitution. Next, fourth topic, loops, functions, argument parsing, traps, arrays. Next, fifth topic, text processing and regular expressions, grep, SED, arc, fundamentals, POSIX fundamentals. Next topic, shell environment variables, export, path, startup files, job control, foreground, background, jobs, signals, etc. This is about first unit. This is second unit. This is entirely related to file system programming and management. This is purely based on the C programming language in Linux environment. File input output system calls, open, read, write, close, lseek, file descriptors, error number, p-error. Second topic, standard IO versus system calls. Third one, file metadata and attributes. Fourth one, directory operations. Fifth one, file system types. Sixth one, file locking and advanced IO. Seventh one, build automation with make. Okay, so these are the different topics related to the just fundamentals of Linux programming. Now we will start about introduction to Linux operating system. Here, Linux means usually the different types of users are there. They are familiar with Windows operating system, but Linux operating system is rarely using by various users in the world because Linux is based on Unix. For Unix there was no GUI interface. Okay, that is the reason the people they were neglected to use the Unix operating system. Similarly, the Linux operating system. But nowadays, the usage of Linux operating system it is keep on increasing because of security only. Here, Linux is an open source operating system kernel that serves as the foundation for the wide range of operating systems. Okay, it was developed by Linus in 1991. Since then, it has evolved into one of the most powerful operating systems which are available in today's market also. Okay, the Linux model is built with emphasis on collaboration, making it easier for contributors worldwide to contribute to its improvement because it is not a licensed version, it is open source, and it is not under the control of any single person or single organization or single enterprise. It is taking contributions from various technical persons in the world. So that is the reason it is available in the form of open source. So that is the main advantage from Unix operating system. Similarly, the Linux operating system. The Linux operating system is the extension of like Unix only. It is simply based on Unix operating system. Now, what are the characteristics of Linux? Just now we have discussed about open source. It is open source. Its open source nature means the source code is accessible to anyone to contribute, modify, and share the code. Here, the source code is available to all the technical persons in the world. Whenever they want to increase the effectiveness of Unix operating system, definitely there is a lot of scope is there. They can download the source code and they can modify the source code and they can extend the source code and they can include some more features to the existing. So all these things are possible when it is a open source software. So that is the reason here so many contributors in the open source community are available to work on Linux operating system development only. So this is open source. Second one is reliable. Its stability and reliable nature make it the perfect choice for critical systems and servers. Okay, reliable means when there is a job given to the means Linux operating system or Unix operating system, we can say 100% reliability is there. So that is the main advantage from Unix or Linux operating system. But miss that is the miss one of the fundamental characteristics of Linux operating system. Next one is multitasking. It supports multitasking, means multiple tasks are executing parallelly. That is the ability of Linux operating system. Means parallelly you can take printout and you can work with some office applications. It okay? Similarly, you can send email also. So these are like parallel, and parallel processing is possible in Linux operating system. And multi-user. So just we know very well means when there is operating system, usually multiple users are working with the same operating system. It okay? Means it is like a client server model. It okay? So when there is a server, different clients they are connecting to the server, and they are they are completing different types of tasks with the help of the server. So here also same thing. Here multiple users means multiple users are able to work with the same operating system parallelly. So that is the main advantage from the Linux operating system. And security, just now we have discussed, it is secure because its kernel means do not allow any person without any permission. Okay, so it is its kernel is very strong. No one can crack the Linux or Unix kernel. So that is the reason most of the software companies they are trying to shift from existing operating system to the Unix or Linux operating system because of this reason only, that is security. Next one is portability. Means, its portability nature has led to its wide adoption in diverse environment from embedded systems to and smartphones to servers and means everywhere you can use this particular operating system because means it is capable to adjust with embedded systems, smartphones, servers, supercomputers, everything. That is the main advantage from the Linux operating system. Next, command line interface. It offers a powerful CLI, providing users with extensive control over the system function. Means command line. Means with the help of command line also you can use the entire operating system, and you can run the entire operating system. That is the main advantage from the uh, Linux operating system. Please, distributions in Linux. A Linux distribution is a complete operating system built around the Linux kernel. Means the kernel is must for any Linux operating system distribution, and it is combined with system software, libraries, and applications. It provides users with everything needed to run Linux on different types of devices. So that is the main advantage from Linux OS distribution. Okay. A distribution includes usually suppose there is a Linux operating system. Usually it contains Linux kernel, system libraries, and essential software tools. Here different distributions are designed for different purposes such as desktops, servers, embedded systems, supercomputers, etc. Okay? The means it is based on the situation. It is based on the need. Means suppose there is a need of a desktop, or there is a need to build one server, or there is a need to build embedded systems. So based on all these things, it means that will be designed. Okay, and each distribution comes with its own package manager, desktop environment, and default applications. So whatever you want to take, you can take any distribution of Linux, and everything has their own package manager, desktop environment, and default applications. Here, user can select the distribution based on their need. Around 600 Linux distributions are available in today's technical world. Some of the popular Linux distributions are MX Linux, means Manjaro, Linux Mint, Elementary, Ubuntu, Debian, Solus, Fedora, OpenSUSE, Deepin. Okay, among all these things, usually most of the persons in academics, they are using Ubuntu, Debian, Fedora, and Red Hat Linux, and OpenSUSE. Okay, these are very popular in today's market. What is the importance of Linux? Linux is a free open source operating system known for its flexibility, stability, and strong security. It is widely used in personal computing, server environments, enterprise systems because of its performance and customization capabilities. It offers high security stability, making it ideal for servers and development work. So definitely because of high security and stability, most of the companies, they are using Linux operating system for their own servers. It is fully open source and free to use, modify, and distribute. Suppose so many companies are there, so many enterprises are there. They are trying to enhance the performance of Linux operating system, uh, and they are giving their contribution to the Linux operating system. Okay, highly flexible and customizable to suit different users and industry needs. So here already we told different Linux operating distributions are available uh, based on the need. Suppose some of the companies, they want to use Linux operating system for their desktops, or for their servers, or for their supercomputers. So based on their need, they can select the proper distribution perfectly. So here Linux operating system has some architecture. It is like layered architecture, some different types of layers. Okay. So here the lowest level layer is, that is hardware layer, and the hardware layer contains CPU, memory, and IoT, input output devices. Okay, next, kernel space. Kernel space means it is like we will discuss about the kernel. It is kernel space, it contains the core operating system services, which are important when there is a need of high security to such operating system services. Those are comes under kernel space only. Next, user space. These applications, user programs, all these things comes under user space. We will discuss about kernel space and user space, and shell and utilities. So here, shell, it is like the interface between uh, user and the kernel, because as a technical person, easily we can use the services from the shell, but we cannot usually it is a little bit difficult to use the services which are given by the kernel. Okay, that is the reason there is a need of some interface between user and the kernel. So those interfaces are like shell and utilities. Means different types of utilities are there, and different types of shells are there, and you can use any shell for interacting with the kernel. It okay, because the kernel is lowest. It provides lowest level of services. Okay, that is the reason. And this one, this is the overall picture of a Linux layered architecture. The innermost layer is hardware. Uh, After hardware, you can find the component that is kernel, means that is like a Linux kernel, and after that you can find shell. Just now we have discussed shell is an interface between the user and kernel. So that is the reason after kernel shell will be there. After that user applications, means like user. Okay. So exactly the shell is in between the user applications and the kernel. So that is the reason it is like the interface between the user applications and the kernel. And also you can find some set of utilities. Okay, some set of ready-made applications. Those are accessible through different types of utilities. Here, what is a kernel? The kernel is the core of Linux operating system that manages hardware resources and controls communication between software and hardware. Okay, so here it is like a core Linux operating system which manages which is able to manage hardware resources, and it controls the communication between software and hardware. So here we know very well the operating system, it is like intermediate element between the user and the hardware components. Okay, so here also same thing. Operating kernel is like operating system is like kernel. Directly or indirectly, both are almost like similar. So here it handles the process management, memory management, and device control. The kernel should take the responsibility, and its characteristics are it should able to handle the process management, and it is able to handle the memory management. It should able to handle device control. So these are the fundamental things which are under the control of kernel. And second one is prevents conflicts between multiple running programs. We know very well when you execute any application, that application uh, should be under the control of OS. So when you execute 10 applications, so definitely those 10 applications are under the control of the operating system only, that too under the control of kernel only. So in such scenario, how it manages multiple running programs. So that is the main task of the kernel. It knows very well how to handle multiple multiple process, we can say, or multiple running programs. So here mainly we will discuss about the types of kernels. Okay, the types of kernels we will discuss in next slide. uh, those are like monolithic, microkernel, hybrid, exokernel, etc. Now, the second part is system libraries. System libraries provides essential functions that allow applications to interact with the kernel without needing to access it directly. So definitely there is a need of some libraries. Those are like system calls. Okay, here indirectly we are able to access the kernel with the help of system libraries only. So it contains reusable pre-written code for common system operations, and it acts as an interface between applications and Linux kernel. So these are different points are related to the system libraries. So here system libraries, we can find many system libraries, and with the help of those system libraries we are able to access the Linux kernel directly. Okay. So what are the different types of important kernels? First one is monolithic kernel. All operating system services run in kernel space only. Okay. So whatever services are being provided by the operating system, those services are under the control of this operating system only, and those services are under the control of kernel only. Okay, but when there is a service, this service is under the kernel, definitely its processing speed is very high, but less fault isolation. Fault isolation means, suppose when there is a problem occurs in one service, automatically it affects the remaining services. So that is not at all acceptable. Okay, even though the execution time is very high. What are the examples of such monolithic kernels? Unix OS, Linux OS, OpenVMS, XTS 400, etc. You can find so many operating systems are available which has monolithic kernel. The second one is microkernel. Means minimal kernel functionality. Means most of the services are moved to user space, because already we have observed one of the main limitation in the kernel space. That is the reason. Wherever possibility is there, such services are moved from kernel space to user space. So when it is under the control of user space, we cannot find any security threats, because its permissions are very limited when a program is under the user space. But it is a little bit overhead. What are the examples? Minix 3 and Mac, etc. Okay. And the third one is hybrid kernel, and it mixes monolithic and micro kernel ideas. Some services in kernel for speed, others are isolated for safety. With some important services, when there is a need of some speed service. In such scenario, those are under the control of kernel only, and remaining are under the control of user space only. So here, what are the examples? Windows 2000, XP, Vista, 7, 8, 10 versions, etc. Mac OS, XNU, Haiku OS, many operating systems are available, which are under the category of 3, hybrid kernel. Now, what are the responsibilities of the kernel? So here, first of all, process management and scheduling. So when there is a program, when the program is under execution, that is called a process. Such a process are under the control of kernel only. Okay? Means process management means different types of process are available, and it takes care about the process creation up to process termination, and it is means kernel is responsible to schedule to schedule and execute those processes successfully. And the second one is memory management. So here means we can find primary memory and secondary memory. The primary memory, its size is very limited. In such scenario, it is able to handle the primary memory and virtual memory with the concepts of paging and frames, etc. And third one is device drivers and hardware abstraction. So here, when there is a hardware component, parallelly we should find out the corresponding software, that it is called a device driver. So such device drivers and hardware abstractions are under the control of kernel only. Next, file system management. So here we can find so many types of files, so many categories of files are available under the control of operating system. And inter-process communication. So when there are multiple processes and there is a need of some communication between processors. So in such scenario, that concept is called inter-process communication. That is also under the control of kernel only. network stack implementation. So when there is a client server application, node to node communication, such things are also comes under the kernel only. Next, shell. The shell is a command line interface that allows users to communicate with the operating system by entering the commands only. That is like command prompt is there. With the help of a command prompt or with the help of a shell scripting also, you can execute different types of user commands, and it is able to interpret and execute such commands directly. And it acts as a bridge between user actions and kernel processing. Next one is hardware layer. The hardware layer consists of physical components that execute commands and provide system resources. The hardware layer usually contains a CPU, RAM, storage, input and output devices, and it communicates with the operating system using device drivers and the kernel services. And system utilities. These are like a system calls. These are like built-in tools which helps the users manage, configure, and maintain the operating system. It is used for tasks like software installation, user management, and monitoring. Simplify system administration process for both beginners and administrators. Next, user space and system components. Here, already we have observed kernel space and user space. Now, we will discuss about the user space. The user space includes shells. Different types of shells are there: bash shell, Z shell, shell, and so on. And system libraries here, GLI, BC, etc. And system utilities. Those are like commands ls, ps, stop, grep, and so on. And desktop environments, genome and kde. These are popular desktop environments. Next, application softwares. All these comes under the control of the user space only. Here already we have discussed Linux distribution, popular Linux distributions, and we will check what is the importance of those distributions. First one is Ubuntu. It is like a beginner friendly, and it is widely used in the entire technical world. And the second one, Red Hat, CentOS, Rocky Linux. These are for enterprise misuses. And Debian, it is very stable and secure. And Arch Linux, lightweight and customizable. And Kali Linux, it is most popular Linux for cybersecurity and penetration testing. Here we will discuss about kernel space and user space clearly. Here it is, kernel space is the privileged realm where the heart of the operating system, the kernel, resides. The responsibilities for interacting directly with the hardware components, controlling memory, and managing system services. The kernel is a critical part of the operating system which requires a secure, isolated space, hence the kernel space. So here it should be like very secure and no any harmful software access the kernel. Okay, and it is also providing so many services, memory management, process management, process scheduling, many things are already we have discussed about these things. That is about kernel space. What about user space? User space is unprivileged territory where user mode applications get to play. Yes, each application gets its private memory space, ensuring that it cannot interface with others or the kernel. This separation safeguards system integrity and facilitates efficient task management. So here it is able to execute the user defined programs only, and it is not able to access others and the kernel directly. Okay, so this is the picture. When there is a different types of applications under user space, and directly or indirectly it should access the kernel space through the system calls. Those system calls are predefined system calls. Okay. And here the right side picture, user application, GLIBC, those are comes under user mode. And what about kernel mode? Kernel mode means system call interface, kernel, hardware, all these things comes under the kernel mode. And this is one more picture. When there is a user space, bash, and some other commands are there, it should access the services which are available in the kernel space through different types of system calls, that is like get PID, open, read, close, etc. Okay. And this is about the difference, the comparison between kernel space and user space. First one is a privilege level. Kernel space, it is very high. User space, it is limited. And access, direct hardware access, but in user space, indirect via kernel system calls only. As a stability, it is critical. It is user space isolated from the kernel. And examples, kernels and device drivers comes under kernel space, and applications, shells, GUI are comes under the user space. These are the different types of applications of Linux. It is like a backbone of a cloud computing, AWS, Azure, GCP, etc., and used in servers, IoT, Android, and supercomputers. Preferred for cybersecurity, AML, DevOps, and embedded systems. Open source ecosystem encourages innovation and learning. These are different types of commands. Okay, we will discuss in next class also. Anyway, these are like brief. LS, it lists the content of directories. CD changes the current directory. PWD means present working directory. CP, MV, RM used to copy, move, delete files means respectively. Free, it shows the memory usage. And DF, it checks disk space usage. Top monitors running process. Netstat, if config, misping. These are like troubleshooting of networking connections, etc. Okay.